Hey guys, hope you're doing well. Today we're starting 29.3 notes. If you look at your calendar, it looks like there's quite a lot of new assignments and videos to watch. There will be videos, but really this lesson today, which may take 3 videos to make, um, is really going to lead into tomorrow and then 24 day 2 and 24 day 3. The homeworks are going to be pretty short, just a couple questions, and all this stuff kind of flows together. It's not really new lessons, but 29.3 is pretty important, and there's quite a bit, maybe a couple new things today. But again, 24 is not going to be very new when we get to that. It's just a lot of extra practice. So we're starting here in the note pack. Now these two paragraphs aren't going to make a lot of sense right now. If I remember, I'm going to come back to these at the end, and hopefully it'll kind of make more sense. But go ahead. Actually, I'll just go ahead and read through them. It says, in the graph of a rational function, so let's stop there. What's a rational function? That's what we've been studying. So there's a polynomial on the top, a polynomial in the denominator. So when we graph these, a break in the graph often signals that a discontinuity has occurred. Algebraically, a discontinuity happens for values of x that cause the function to be undefined and are therefore not in the domain of the function. So we're going to talk about not really the word discontinuity, but a hole. So if I have a graph, now let's say I have a graph that looks like this. See that little hole right there? We're going to have a hole in our graph at times, or maybe my graph will look like this. See that little hole right there? That's what's going to happen today, and this kind of tells you how, but we'll talk about it more in the examples. Common factors that are divided out of a function during the simplification process produce holes in the graph, rather than asymptotes. These holes are called removable points of discontinuity. The domain of a rational function does not include the values of x where there are holes or vertical asymptotes. So discontinuity, holes, removable points of discontinuity, that's kind of all saying the same thing again. If I have, if I'm going from 0 to 10 on my graph, and my graph looks like this, well, this is not part of the domain because there's no value there. That's what this is saying. All right, let's take a look at some questions. Number 1, identify any vertical asymptotes and any holes in the graph. Before we figure out the asymptotes and the holes, let's go ahead and factor the top, the numerator, and the denominator, and then we'll work from there. I have put this over here to show you how different this is than the parent function. You don't need to write this, but I can't just look at this f of x graph over here on the left and be like, oh yeah, that's left 4, up 6, and all of that kind of stuff. That's not the way it's going to work, because it doesn't look like this. There's an x on top and on bottom. Only if it looks like this and is a transformation can we do that. So today and in the next couple lessons, our functions are going to be a little bit more complex. So let's factor. Again, pause at any time because you might take longer to factor. So the top, x plus 2x minus 2. The bottom, x plus 3x plus 2. Well, we know that if there's a common factor on the top and the bottom, those cancel. So it's going to simplify to this. Now, when we are done simplifying the numerator and denominator, we are ready to do our vertical asymptotes and our holes, which are the questions. So the vertical asymptote, look at your denominator. What can x not be? What value of x will I not have? Therefore, there'll be a dotted line. And you can tell x is going to be negative 3 is going to cause a vertical asymptote. There'll be no points at negative 3. There'll be a dotted line called an asymptote. The hole. Now, if you go back and read this again, which I'm not going to do, it's going to tell you basically right here, common factors that are divided out of the function during the simplification process produce holes rather than asymptotes. So see how these got crossed out in the simplification process? That produces a hole, not an asymptote. So the hole, see what I crossed out here, was the x value would be negative 2. Now it's not an entire line, so I actually don't want you to write it as a line. I want you to be more specific to where this hole, where that point actually is. So how do I figure out where the hole is? Well, if x is negative 2, which again you're not really going to write as part of your answer, you're going to plug in -2 into this. So if I plug in -2 here, that's going to give me -4. If I plug in -2 here, that's going to give me 1. That simplifies to -4. So that's where my hole will be. So in your homework, if I give you this question, I expect to see it simplified, things crossed out, and then your vertical asymptote will be a straight vertical line, x equals a number. Your hole will be a point. Now, because this is our first one, I want to expand on this question a little more, even though we're done, just so you can kind of see what's happening. So let me grab my graphing calculator here. You can do this with me, or you can just kind of follow along. I have typed in the original problem without simplifying. Here it is, and here's the graph. Can you see a vertical asymptote? Can you see a line where there are no values? But right here is your vertical asymptote. Does that look like x is -3? Yep, x is -3. Now, where's that hole? It says -2, -4. Well, -2, I don't see an asymptote there. But watch what happens when I zoom in. Let me go to a window of -3. Sorry. -3 to -1. See why I picked that? Because I wanted my x's to be, so I could see -2 really clearly. And then my y value, I'll go from -6 to -2. We'll see if that shows up well. You don't have to do this, but you can just see that hole there? That's because I zoomed in now. My window's really zoomed in, and that's the hole. The vertical asymptote was over here, but this is the hole I get. And you normally don't see it unless you zoom in, but it is there. So that's just a hole, a point of discontinuity. It's not continuous. It stops at that x value, and then it keeps going. So we're not going to graph all these, but I just kind of wanted you to see that there is a hole. You just might not be able to see it unless you zoom in. Sometimes you have to zoom in really, really well to see it, and sometimes even then I have a hard time finding it depending on the graph. All right, so let's take a look at number 2. Same directions. Identify vertical asymptote and any holes in the graph. So you're going to factor. Go ahead and pause it and factor it. I got this for these are my factors, and my common factors that get crossed out in the simplification process are those. So when I cross those out, I like to clean up my function a little bit. So numerator, denominator. Now I need to list my vertical asymptote and my holes. Vertical asymptotes. That's going to be a vertical line, and look at your denominator. -4 is where you're not going to have any values. And the hole, that's the new part for today. That comes up here where things got crossed out. So if you look, your x value would be 1, because 1 minus 1 is 0. Just like down here, -4 plus 4 is 0. So x equals 1 is where it's going to be, but specifically the hole is at a point. So please, in your answer, don't leave this. That's just kind of to help you figure out the first part. Now, how do I find the rest of the point? I plug that value, that 1, in here. Because if you plug it in up here, you're going to get undefined, because you're going to get 1 minus 1 is 0. So go ahead and plug in 1. So that's going to be 1 over 5 is where your hole is at. And these are your answers. Number 3, go ahead and get started on it. It's going to be helpful if you put your leading coefficient like in standard form. And then I'm also going to take out a negative because we don't like to work with negatives on the leading coefficient. So if I take out a negative from the top, factor it out, that would be negative parentheses x minus 3. Factor out a negative from the bottom, negative parentheses x squared minus 9. Okay, the top isn't going to factor anymore. Oh, sorry. Negative over negative cancels, simplifies, so I took those out. So my numerator is x minus 3. My denominator factors, x plus 3, x minus 3. that goes away, that goes away. What happens if there's nothing left on the top? It's just a 1 over x plus 3. Okay, we're ready for our questions. Vertical asymptote is a line, and you want to look right here. What value is going to make the denominator 0? -3. And the whole is going to be up here, depending on what got crossed out. It looks like 3 would be my value here, creating a 0. So 3 in the x spot. Sorry, I need to change that to a 3. Positive 3. We don't want to write this for our final answer. And then go ahead and plug 3 in here. So it's going to be 1 over 3 plus 3 is 6. So 3 comma 1/6 is the whole. Good thing about number 4 is it's already in factored form, so you don't have to factor. Let's just start simplifying. So x plus 4, x plus 4. So we know we're going to have a whole. Because that got crossed out, we're going to have a whole at 4 comma something. We'll fill that out later. Notice the x's cancel also. Well, think of x as x plus 0, because that's pretty much what it is, just like x plus 4. If it's just an x, it's x plus 0. So I also have another whole, since x got crossed out, at 0. And let's just go ahead and simplify. That's going to be 2 over x minus 6. My vertical asymptote, look at the denominator. The x value that would make this 0 is 6. X equals 6. And I have two wholes at 4 something and 0 something. So plug in 4 here. 2 over 4 minus 6 is -2, which simplifies, can't be right, to 2 over -2. 4 minus, yeah, so this should be -1. So one of my wholes now is correct, is -4, 1. I don't need to write that because it's not actually a line, it's a point. And then plug in 0 here, so that's going to be 2 over 0 minus 6. That's 2 over -6, which is -1/3. Okay, so there's my vertical asymptote. There are my two wholes. The next page is just a summary, especially the top half. It says vertical asymptotes depends on what the x values that you cannot have. So here's a summary. If the factor of the top and the bottom cancel, the x will be a whole. That's the simplification process. If the factor on the top and bottom do not cancel, then x equals the value that makes the denominator 0 is the vertical asymptote, like we just did in the last couple examples. You can read through these if you want. They're excerpts from your book. And then I'm going to start the next video by this bottom part, which is going to be new.